45 minutes. I've done this before. So let's start. Okay. Let's see. First thing is I know this doesn't exist. Let's just, for the argument's sake, how many characters do we need? Shortener number. Let's see. Oh man. Still don't know. Yeah. Okay. Let's just keep it one by. Let's assume that we have. Well, let's work backwards. Instead of doing this, let's just do users. Active words. Let's say they expire in that's a good number. So we need system How do we do that? Zooming. So zooming how many users? Is that enough? Yeah, let's assume that that's the case. Else that would mean to shortened fashion. No. Okay. I mean, if someone shares a link to, let's say, an Amazon posting, that's definitely going to be way more. So we've got to make it. What do we do? We do our characters. That's good. Yeah. To our characters, but since it's all ASCII, it'll each fit into a byte. So we can just say 200 bytes. Yeah. Plus a bytes for output. We just need the shorthand for it because we can just having 8 bytes. Can we serve? Let's see. 8 bytes would be yeah, 26 plus 26 plus 10. That's the capital A to Z, lowercase a to Z, and the digits 0 to 9. This is per byte. That's 62. Yeah, 62. So if you multiply them, I mean, it's not multiply, it's 62 to the power of 8. Right? Yeah, 62 to the power of 8. That's how many you can have. Let's assume the 64 for the sake of math. Right? 64 is 2 power 6. Power 6. 6. Power 8. Right. Yeah, that's a lot. That's 2 power 48. And we know that 2 power 10 is roughly 1000. That's 1024, roughly 1000. Which means that just since we chose 64 here instead of 62, let's make this equal to 2 power 45. Let's just make it 40. Okay. Is roughly okay. Which means that's 1000 to the power 4. No. Yeah, 1000 to, which is roughly billion. Right. 1000 million. Billion? What do you say? No, billions to power 3, so it would be trillion. That's good. Okay, so we're good on that. 8 bytes sounds good. Which means we need 208 bytes in total. Million words. Let's do million words. Million words. That's, since we're doing 90 days, you could have a few inactive ones. Let's just assume that you have 5 times as many in total. So let's just say 4 million inactive. Once they're still in the database, is waiting either to be used or to be removed. So in total 5 million megabytes. That's 200 files, which is roughly about 1 billion bytes. Yeah, so that's 1 GB. It's 1 GB. Right? Yeah. Megas, you have kilo, which is 10 power 3, mega 10 power 6, giga 10 power 9, so 10 power 9 bits, and giga. So yeah, we have that call. That's not a lot of data. I don't know how much. First problem. How much can I have no idea. So that's something we will deal with later. That's just a question for later. Okay. I assume we should be able to catch that. Do we need a database for this? We probably do. If you remove and cache, can't be your only. Can I? Can cache be your only source of truth? Doesn't feel like. You need to have you need it to be saved somewhere before you can. Okay, we'll come up with that later. Okay, so that would be that. So you know what? User interface. That'd be this. So call what's that gonna call? Okay, third, I believe it started on 30 minutes. So the UI is gonna call our server. Right? This is a very crude situation. So then calls let's just do this. Okay, that's fine. So then, yeah, it's the DB, and the DB responds back to the server. No. So what does this guy do? So what we'll do is move this guy out. And expand this to include Can I do this? No. Okay, let's do one thing then. Let's try something else. Instead of a server, let's do 3 surface calls guy in the middle. Let's it has to be some sort. So let's call this. But you could have multiple servers and tons of requests coming in at the same time if you have 1 million active URLs. So start with you need to decide who gets them. So let's do a load balancer, right? Or yeah, and use queues, message queues maybe, and just say is there a possibility of oh yes, we should do that. Yeah, I remember seeing that somewhere. Where instead, how do you ensure that yeah, okay, yeah, correct. How do you ensure that you have different so we've decided that we 8 bytes, right? Yeah. So what we can do is, assuming there's, let's just use 7 of those bytes. 7 of those bytes. Instead of getting a trillion, you would then get I don't know, wait, hold on. We would get 64 less than a trillion, essentially. Yeah. So what we would get is, instead of 1 trillion possibilities, we'll do 7 bytes per except we'll have that's perfect. That should still give us we don't need a trillion here. So a trillion by 64. Okay, that's 2 power 6 to 64, so 2 power 4 to 4, 16 billion, which is what we need. You know what? We can bring it down. We don't need 7 bytes. We can just do 6 bytes for the URL and 7 byte. Okay. Here we go. Let's see. Okay, back to this. That was a small break. Okay, where are we? Yeah, so we use 6 bytes for the URL and 7 bytes for the episode. So what we can do is, when the load ends up being more than what this thing can handle, what's going on. Yeah, okay. So what we will do is just that's not bad. Okay. So this one. Each has its own database at that point. Can we do that over? No, never mind. Okay, that's good. Fine. So this one P1, this will be for the range of range. Okay. 0, 0. Writing an X here. 0, 0, 0, 0. 6 bytes. 2. 6 bytes. That's roughly 1,000. What am I saying? 16 billion. Oh, no. 16? Okay, so 6 bytes. Let's just do the math real quick. 6, and it's 6 bytes. 6. So that becomes 6 is 36. 36 is so that's 2, 4, 8, 16, 30, 64. 64 billion. Something's off. 64. Okay, 64 billion per. And we can just copy that, paste it. Paste it. And so on, we just have a this way we two. Okay, so this is what we would have, where each one of these would connect. So we can do this a number of times. Now the problem is, so this load balancer would have to keep track of which okay, so it could send it in round robin fashion to each one of these. So we'll just round robin fashion, round robin fashion. But so which microservice? So now here comes the okay. So instead what's this guy doing here? Okay, we have the load balancer. Okay. Yeah, so the idea is load balancer talks to each microservice. This one is only spawned when necessary, and allocates that. Instead of it directly giving that, let's just have actually let's make this guy okay. So the queue yeah, the queue system should work. So that's the idea. So you could have a message here so that you have multiple yeah. But then so you have a queue which this guy just pushes to in a hot fashion, so in case it's taking a while to process, some things remain in the queue for whatever reason. You could have a small delay or some garbage collector running, anything. So if something's going on, some background process is going on, then it's going to be delayed. And if the load balancer sees that something is not served, okay. Do we need to clean up service? Actually, you know what? But do we? No, this is ineffective when it comes to inefficient when it comes to generation and fetching. I mean, this generation makes sense. This pattern makes sense for generation, but for fetching, we could have a separate queue. No, that doesn't make sense. Fetching also has to go through the same thing. You would have two different. In this case, a microservice handles both generation and fetching, because this is the better way to do it. You would have the database here, but if it were to make sense, okay, we can do. Let's have another database. Can we? So old recent fetches. You can't clear after 30 days. How do you do the clearing system? I don't know about that. mean, yeah, we would only have issues when there's an expiry of one of these. So I would say the first thing the load balancer would do is check, does this load balancer deal with cache? I don't know. Yeah, I think that's a merger. So let's cache first. If it's present, sure. If not, questions. Just there's one dropping one and just goes on. Yeah, so this is the final. This is, I think. Okay. Now we have a minute, so let's just write down the API for it. It starts with input like this. This would be, the request would have okay, that's exactly it.